Okay, today we're going to do section 7.2, which is on graphing polynomial functions. Now in section 7.1, we did graph polynomial functions that are zeros or x-intercepts. You could always find with factoring. Some zeros aren't really that easy to find. They may be between two integer values, such as -1 and -2. Also, we didn't really know how high or low the graph was, so a t-table can also help us with that. We really just had a rough sketch. We could make things a lot more formal with doing all of these things together. So factoring, time to zeros possibility of using a t-table of better values. All right, so we're going to actually just use a table of values to find the next one. I actually found some of these values for us already. So if I plug in 0, that's the easy one. You just get 5, the constant out. So 0, 1, 2, 3, 4, 5 at this point. When I plug in 1, I get 0. So that's one of our x-intercepts. If I plug in 2, I get -19. So that one bounced way down to the side. So 2 and -8. All right, I'm guessing if I plug in 3, I also get a large number. So let's go to the negatives. The -1. When I plug in -1, I get 2. Now when I plug in -2, I get a -3. What's down here? So this tells us that our graph, since polynomials are smooth and continuous, the graph had to go down through here. So that means it had to cross the x-axis somewhere between -1 and somewhere between 2. So it's because these numbers here change from positive to negative. Alright, so there's 0 for an x-intercept. Between x equals -1 and x equals -2. All right, let's try some more values. If I plug in -3, then I get -4. If I plug in -4, I get +5. So once again, that means our graph had to go through the axis again, because they're going to be nice continuous functions. So we have another 0 between -3 and -4. Oops. Okay. Okay. Now if you try -5, you go way up to 30. So it's really low. Okay, so that means our graph probably looks something like this. Now, relative maximum and relative minimums. Right, these are also called local maxes and local mins. Basically, these are all just the hills and valleys of the function. So if I have something that looks like that, my relative maximums are right at the top. So notice those aren't necessarily the highest points on the graph. You know, you could have something that just keeps getting higher like that. These are all still relative maximums. Maximas, all right, local minimum. If I'm talking about the local minimum, those are just the valleys. So those are the bottom. So I always like to think if I like zoomed in on one point, so I zoomed in right there, that point is kind of like a person standing on top of a hill. And that person is higher than every person on it. So they're on the highest point possible in that zoomed in. All right, so number 1. It says determine the consecutive values of x between which each real 0 of the function x to the 4th minus x cubed minus 4x squared plus 1 is located, and draw the graph. All right, so I'm going to do another t-table for this. Now, I guess it's also interesting to note with the relative maxima and relative minima, if I have an x cubed function functions can look like this. That's not necessarily the x cubed function, but it's just an x cubed function. It has one relative maximum, one relative minimum. an x4 function we learned last section. We can look at that next. So see why I have 3 relative maximum and minimums. An x to the 5th, it looks like that. 1, 2, 3, 4. So basically, whatever degree we have, the number of bumps or valleys that we have is one number less than it. So that's how I knew in number 1, so this one right here. That's how I knew that I was done with this graph, because I had a valley and I had a hill. And that was the most I could have because I had an x cubed function. All right, so let's continue with this one. So I have 0, when I plug in 0, I get 1. Okay, when I plug in 1, I get negative 3. When I plug in 2, I get negative 7. And when I plug in 3, all of a sudden I get 19. So that was right up there. Okay, so that means that between 2 and 3, well, I have it cross the axis. So we have a 0. So 0 between 2 and 3. All right, let's say I try negative 1. If I try negative 1, I get negative 1. If I try negative 2, I get 9. So that means I've now gone from positive to negative again. So that now there's a 0 between negative 1 and negative 2. So I'm always staying between the x values. Right, if I try negative 3 gives me really big 73. So I know it's going back, it's just going up. I also know that I'm not done because it's x to the 4th, and I have my 3 relative maximums slash minimums. So I know I'm done. All right, so where are my zeros? Let's look at the help us. We had the 1 that was between 2 and 3, that was right here. We had the 1 that was between 1 and negative 2, that was right here. See? We had, it looks kind of like a 0 there, but it's not really 0. We have 1 that's between 0 and negative 1. That's what I'm guessing, and you can confirm, yep, that one's 1, that one's negative 1. So the signs went from positive and negative. All right, and it looks like I have another one between 0 and 1. Let's check that one out. So 0 and 1 is there. So check out 0 and 1. So 0 and 1, yep, it goes from positive to negative there as well. So there are 4 zeros. So 0 between 2 and 3, 0 between negative 1 and negative 2, 1 between 0 and 1, and 1 between 0 and negative 1. So we have 4 zeros. Right. That was the end of 17.